All right, welcome back to Computer Science S76. This is the last time we'll meet in this more formal setting. Recall that next Wednesday is our app party, at which point all of your projects will be more than several days done, most likely, and we'll gather in the lab room and we'll have some cake and some snacks and some chit-chat, and the goal will be to bring your app, to bring your laptop as appropriate, and actually demonstrate what you did not only for your last project, but maybe your first project or two as well, particularly if you took a novel approach to the user interface or generally just want to show off. So tonight we wrap up our look at iOS, but first a couple of thanks. You know that we've had a team of folks behind the scenes here and in front of the camera, namely Chris and RJ and Rob, so I just wanted to publicly thank them for all of their efforts thus far. Thank you. And also to folks you haven't probably met in person, but Shelly and Ramon and Dan, who've been running things behind the scenes. So thank you to them as well. Just in case you would like to relive this summer experience, realize that the videos will remain online at cs76.tv for the next few years, most likely, for better or for worse. So if after the class ends and you're back in school or back at work, you'd like to at least review material or pull up PDFs or sample code or the like, know that that will continue to survive on the internet. So feel free to tune in there. So a couple of outstanding details here. So we started the semester looking and talking about web apps versus native apps. Someone want to recap in just a sentence or two what the distinction is and was? 5 weeks later? What's a difference?
So the web apps are much more portable because you can use them across browsers.
OK, good. So web apps are much more portable. You can use them across browsers.
So we can't access any of these special tools of the phones like accelerometers.
OK, good. But certain special hardware is typically inaccessible to you. Things like the accelerometer, for which browsers like Safari and the like don't necessarily provide an API to. Good. Other thoughts?
Native apps run natively on the iOS, whereas web apps have to be downloaded every single time you make a connection.
OK, so web apps do have to be downloaded via HTTP in the context of a browser before they can actually be run. But you kind of give us a circular definition before. What does it mean for native apps to be native? OK, good. So you don't have to retrieve them from some other source other than the first-time installation from the App Store, which is another compelling feature, perhaps. Most people know how to find apps in the App Store, but most people probably don't know how to actually bookmark a web page so that it appears to be an application, which was a technique we looked at way back early on. So if you had to choose right now for your third and final project, which you do, how many folks are leaning toward or already down the road of web apps? OK, so a handful, 6 or so, and native apps. OK, and most everyone else. So not bad at all. So we'll have a good mix of at least both at that final class. So all right, so that was web apps versus native apps. What if you didn't necessarily have to choose between two such stark contrasts? Well, it turns out that there are wrappers, the most popular of which is probably something called PhoneGap, which allows you to write web apps but create the illusion of them actually being native apps. And by this I mean you go to PhoneGap's website and you download what's essentially starter code that they have written for Objective-C, for Java, for Windows Phone, for a whole bunch of other platforms as well. And they've implemented in different ways in each of those languages hooks into the native hardware, and then have exposed that via JavaScript to web code. So in short, you could, in theory, implement an application entirely in HTML5, CSS, and JavaScript, but you could actually ship it to the Apple App Store, and a user could download it, and they would have an icon, and they would have gotten it for free or 99 cents, whatever the case may be. And when they run it, it's actually native iOS code running on the phone, but the contents of the rectangular window are largely coming from some website externally. In fact, this is how the earliest version of the Facebook application was written. Some of you might recall that it used to be much slower, which is actually a downside of taking that approach. You don't necessarily get the same lack of latency that you might in an iOS native application. But the upside is, 1, you don't have to learn Objective-C and iOS. 2, you have access to tools and more familiar environments, which for most people is web-based these days. And 3, I'm kind of out of reasons. So 2. So you have 2 pretty compelling reasons. So how do you go about doing this? Well, technologically, this is actually implemented in kind of a clever way. So first and foremost, this technique using PhoneGap actually gives you access to quite a bit of hardware, in contrast to what we proposed was the case a few weeks back. So all of the green boxes here represent native hardware that is supported on Android, BlackBerry, iOS, Windows Phone, and so forth. Things like the accelerometer, the camera, the compass, and other details that are typically inaccessible to JavaScript. But by downloading this starter code, which is native, you're therefore providing a bridge of sorts between native code and JavaScript code. And the means by which they did this in the iOS platform, though it differs on others, is the PhoneGap folks essentially register with their iOS native application URLs of the form gap : / and then something. And they essentially have an MVC style approach here where you can then specify as part of this URL a class name and a command or a method to actually call, and then some number of arguments. So in other words, they kind of made up their own sort of faux protocol by teaching iOS to handle URLs that appear inside of a browser window via code that they've written. So it turns out there's a protocol called UI WebView Delegate. And if you implement this, you can actually be the code that is invoked when an otherwise foreign URL is used in the confines of an embedded web browser. And indeed, that's how PhoneGap works. You write web code that you therefore embed inside of a rectangular window that's just an embedded web browser. And if you want to talk to the native hardware, you essentially do this by way of the URL bar. So this delegate class allows you to specify what code should get invoked when the embedded browser window sees a URL that starts with gap : //. And meanwhile, there's also a UI WebView. This is the class, even if you've not used it before, that allows you in iOS code to embed a browser inside of your own native app. And it turns out there's a method associated with this class called string by evaluating JavaScript from string, which means that your code can be injected into the local browser and then executed by way of this method. So in short, this provides a bridge of sorts between native iOS code and the browser by way of this URL-based trick. And there's one other step to this, whereby, well, rather, in other operating systems, this is done a little bit differently. But in short, Apple provided enough in the way of hooking that folks like PhoneGap are able to come along and allow you to implement your next app as really a web app underneath the hood, composed almost entirely of JavaScript with a bit of Objective-C that some other folks have written. So I would consider that perhaps for your next project well beyond the course if that's of interest. Questions? All right, well, what about provisioning? Sadly, some of you have struggled with this past week. As you may know, a hacker or some persecuted white hat type person found some vulnerabilities in Apple's developer portal, the result of which is that he was able to compromise, supposedly, a whole bunch of names and email addresses of all of us who have perhaps registered for the iOS developer portal. And to my knowledge, this was the first time that Apple proceeded to take the entire thing offline for, I think, over a week, which is wonderfully poorly timed for someone like us. So apologies to those of you who have struggled with this, but this means now that the thing is starting to come back online, you can in fact provision your device to run software written by you. So if you have an iOS device, iPhone, iPad, or iPod, you can eventually, if not already, go to a URL like this, follow the online documentation, and frankly, this is one of the biggest headaches of iOS development, just getting your damn code onto your own phone. It's not nearly as simple as it is in the Android world or in other platforms, because you essentially have to upload a public-private key pair or portion thereof to Apple so as to register some cryptographic key with them. Then your code has to be digitally signed in such a way that it's allowed to run on your own phone, even if you're doing all this at home with a USB cable. And this costs you only $99 a year for this privilege. So long story short, this is a huge headache. And every time I go, it changes every year. But you can kind of muscle through it with the documentation, which has gotten better over time. But the end result is that you can run the software on your own phone. If you want to distribute it to friends, you'll have to go by way of the App Store, or there are ways over the air that you can distribute apps for testing's sake. And there's also, for those of you who work professionally, there's an enterprise level account for $299 a year, or $199, that allows you to share code that you've written with other folks on a development team, which makes it a little easier to at least share and test software among each other. So not a particularly fun process, but there is quite a sense of gratification, I think, once you've gotten your own code working on your own phone. So aspire to that perhaps for next week and realize you don't have to pay any of those fees. Assuming the Member Center, as it's called, is back up and running, we can provision your phone for you. You can fill out the form that's linked on the course's website and in the specifications so that you can then use our academic account, at least for the remaining couple of weeks of summer school. All right. So we're fortunate today to be joined by folks who will bring us two different perspectives on how mobile software development can be done. First is Dan Armendariz, who's a buddy of mine and also the former instructor of this course. Back in the day, we dabbled in both iOS as well as Android development. And Dan has come back from California to join us for an hour's chat this evening about how Android development compares and contrasts with native iOS development. We're also fortunate to be joined by a friend of ours from down the street at Microsoft NERD, New England Research and Development.